Hello, how's it going? Yeah, I'm good, thanks. Thanks for asking. Right, let's think about what is the electronic structure of an atom. Hopefully, if you're watching this video, you already know what an atom is and a bit about its structure. If you don't, watch my video on that. But just a quick reminder, atoms have a nucleus in the middle that is very small compared to the rest of the atom that contains protons and neutrons. Around the nucleus is mostly an empty space, but every now and then we find the occasional electron in an energy level outside the nucleus. If you think about any given element, we might want to know how many electrons it's got. And we can work this out using the proton number, the bottom number that goes with the element in the periodic table. In the case of sodium, its proton number is 11. That means it also has 11 electrons when it is an atom. Now, if you are asked to deduce the electronic structure for an atom or an element, you will either be expected to draw it out or to write it in numbers. But before we do it, there are certain rules we need to know to do this. So the first thing is that electrons don't just go anywhere outside the nucleus, they go in energy levels. And they will go in the lowest energy level that they can, as long as that energy level isn't full. And the first energy level, the lowest energy level, will take 2 electrons and no more. The second energy level can take 8 electrons, and so can the third energy level take 8 electrons. And the fourth energy level can take 2 and even more electrons than that. But in GCSE, you would never be expected to talk about the electronic structure of an element that has more than 20 electrons. So let's have a look at calcium. Calcium's got a proton number of 20, so it's also got 20 electrons. So we know that we can put the first 2 in the first energy level. There they go. But now our first energy level is full, so we're going to need another energy level because we've still got 18 electrons left. So we add a second energy level, and watch how I put these electrons in. In exams, always put electrons in like this and you won't go far wrong. I can't really be bothered to explain why this is right now, but just trust me, it will help you and won't ever really cause you any trouble. So go 1, 2, 3, 4, 5, 6, 7, 8, like that. If you do it like that, you won't find you have any problems answering questions. So you can see now that we have added in total 10 electrons and we filled up the first 2 energy levels, but we've still got another 10 electrons to go because we have 20 electrons in total. So we need a third energy level, and again in go our 8 electrons in the same way. We're now up to 18 electrons in total. We need 2 more and they can go in the fourth energy level. There they go. So we can draw it out with dots and circles like that, or we can write out the electron configuration, in this case 2882 with commas in between them. Here are just a couple more examples to help you. So sodium has 11 electrons, so let's put 11 in. 2 in the first shell, that energy level is now full. 8 in the next energy level, filling them in as I've shown you, and that means that we have 1 electron left to go in the third energy level, and we're finished. And again, we can either draw it out or we can write it out as 281. Fluorine is a non-metal, and so we can do an electron configuration for that, or an electronic structure diagram for that in the same way. We can see it's got 9 electrons, and this time I'm drawing the electrons as crosses, but it really doesn't make any difference whether you use dots or crosses. So 2 in the first energy level, and that leaves 7 remaining, so 1, 2, 3, 4, 5, 6, 7, and that is the complete electronic structure for fluorine, which we could write as 2, 7. Now there's a couple of things you're expected to know from drawing these electronic structure diagrams. You're expected to be able to show how this demonstrates which group the element is in and which period it is in. The group is the column in the periodic table and the period is the row in the periodic table. Now the number of electrons in the outer shell shows us the group, and the number of shells shows us the period. So if you look at sodium, sodium has got 1 electron in its outer shell, so it should be in group 1, and it's got 1, 2, 3 shells, so it should be in period 3. Fluorine has got 7 electrons in its outer shell, 1, 2, 3, 4, 5, 6, 7, so it should be in group 7, and it has got 2 shells, so it should be in period 2. Let's have a look at the periodic table to check. Here's our periodic table, and we can see that sodium is in group 1 because it has 1 electron in its outer shell, and it's in period 3. Here's the first row with hydrogen and helium in. Then we have the second row or period, and the third period, which starts with sodium. So sodium, as we saw, has got 1 electron in its outer shell, so it's group 1. It's got 3 shells, so it goes in period 3. And fluorine, if you remember, had 7 electrons in its outer shell, so it goes over here in group 7. And it had 2 shells, so it goes in period 2. There's period 1, and here's period 2. Now, elements are arranged in this way, and it means that all elements, for example, that have 1 electron in their outer shell go in group 1, and they all have very similar properties to one another. All the elements with 7 electrons in their outer shell go in group 7, and again, they have very similar properties to one another. So, just quickly to remind you, you know how to draw the electronic structure for an element now using the number of electrons. And remember, the number of electrons in the outer shell is equal to the group number, and the number of shells equals the period number. If you get all this and think you understand it, perhaps spend a bit of time revising scientists who developed the periodic table. But for now, don't stop believing.